Class 12, I had discussed till question number 13 and I had asked you to try 14. Till 14 I had asked you to try. Some more questions are left. I'm discussing them as well here from tangents and normal. Okay. So like the 15th question is saying find the equation of the tangent line to this particular curve which condition 1 parallel to a particular line perpendicular to some lines are given to you. Okay, so the curve is given to you. If we know the curve, we will proceed to find its derivative. So that was your curve. Then we've taken out its derivative, which will come out to be 2x minus 2. Now, in first part, we were told that our tangent would be parallel to this line. So remember that if equation of line is given to us, we can trace its slope. You can bring it in. Y is equal to mx plus c form. Take y to that side. So it becomes y is equal to 2x plus 9. So from there we know coefficient of x is the slope. Okay, so I've mentioned it here. You can do it whichever way you want. Finding of slope. Okay, or you can just differentiate. That is another way. Okay, finding derivative of any curve gives you the slope of that particular line, curve, whatever it is. Okay, so slope of this line is 2. And since we were told that tangent and this line are parallel, we know for parallel the slope remains the same. So we can equate our dy by dx to the slope of this line. That is, this was our derivative, will be equated to 2, solve to find the value of x. And at that x, you will then find your y, corresponding y. Okay, so that means our point of contact for this tangent that we were talking about is coming out to be 2, 7. All right, and you had to find the equation. So equation of any line at this point, and if we are talking about tangent at a particular point, that would be the point of contact would be y minus y0 is equal to m ki jagah aa jata hai dy by dx, x minus x0. So by that formula, equation of this tangent is coming out to be y minus y1 is equal to slope was 2 dy by dx, x minus x1. Solving it, that's your answer. Okay, now for the same question in case 2, you were supposed to find the tangent which is perpendicular to this line. Okay, so first of all, slope of this line. What would be slope of this line? If I take minus 15x to the other side dividing by 5, y is equal to mx plus c form में लाओगे या derivative करके, whichever way you do it, your m will come out to be, or slope of this particular line is 3. But our tangent was perpendicular to this. In the previous case it was parallel, तो हमने सीधे dy by dx slope से equate कर दिया था, slope of line से. Here we will, whenever two lines are perpendicular, then the product of the slope is -1, or we can say slope of one line is negative times the reciprocal of the first slope. So that is what we've done here. Our tangent was not parallel but perpendicular to this line. So dy by dx, that is slope of tangent, will be -1 times the slope of this line, because they were perpendicular. Okay, so put that dy by dx we had already evaluated was 2x minus 2 will be equated to, if slope of this line is 3, it will be equated to -1 by 3. Simplifying, evaluate your x, find its corresponding y, and finding of equation I have left for you girls. Okay, now the point of contact इस समय आपका आ गया है 5 upon 6 217 upon 36. Okay, so now again the same way you can find, use this equation in place of dy by dx will come in this value -1 by 3, and x naught and y naught की जगह ये आ जाएंगे. Okay, so you can try and complete that question on your own. Okay, what is next is show that the tangent to the curve, this one, at the point x is equal to 2 and x is equal to -2 are parallel. Okay, so if we have already discussed, if the lines are parallel, their slopes are same. So what you have to do out here is simply to check whether the tangents of this curve at these 2 points are parallel or not. Their slope should be same. Orally ho ja raha hai, dekho ye question. If this is your curve, then dy by dx from here would be 21x square, right? And 21x square, because it's a square, so 21 2 square and 21 minus 2 square will be the same. Okay, so naturally dy by dx at 2 is coming same as dy by dx at -2. So we would say yes, the tangents are parallel. Okay, so that's a simple one. Now 17th one is saying find The point on the curve y is equal to x cube at which the slope of the tangent equals to the y coordinate of the point. So that's also simple only. Whatever curve is given to you, you will differentiate that. That will give you your derivative. Okay. So that was your curve, then your derivative, and that derivative is given same as y coordinate. So we can equate dy by dx to y. That is what was told in the question, that the derivative or slope of the tangent, derivative out here represents slope of tangent, is same as y coordinate. Put the values dy by dx from here, y from here. This is your value of y is equal to x cube. Putting both these values here in that equation, simplifying to find your x. You got your x from here 0 and from here 3. Find its corresponding y from this. Okay, so your 2 points satisfying this condition are 0, 0 and 3, 27. Fine. Okay, what is the next question saying then? For the curve, this you have to find all the points at which the tangent passes through origin. Okay, so this is a bit, it's clear actually, but students at times get confused in this. Okay, there is some additional work there, so just pay attention. This is your curve. Naturally, you have to find the derivative for talking about the slope of tangent, because we are talking about tangent and we are saying this tangent is passing through origin. So आपको equation of tangent बनाना पड़ेगा, and because that tangent line is passing through origin, origin means x0, y0, you will satisfy those points. You'll replace your x and y by 0, 0 to form your equation and hence solve it. Okay, so I'll show you stepwise here what has to be done. Question number 18 that was given to you. You were given, this is the curve. Differentiating, that would be your derivative. Now, we are saying let the required point, point, so we don't know. So we are saying suppose that point was x0, y0. The tangent at which would be passing through origin. We don't know, we were not given that point. We need to evaluate that. So we have assumed let the point be x0, y0. Then naturally this point of contact, children, lies on the curve as well as on the tangent, right? ये जो point of contact होता है वो tangent के equation को भी satisfy करता है and curve के भी. So we have assumed that point to be x0, y0. So it would satisfy the equation of the curve as well as the tangent, wo jab tangent banegi, of course. Okay, all right, so I've done that already. So if x0, y0 is that point, then it should satisfy the equation of the curve, and it is also going to satisfy the slope, because slope tangent ka usi point mein nikalenge. All right, so I've done that here. Now equation of tangent we know is obtained like this. Suppose we had said the point was x0, y0, then y minus y0 is equal to dy by dx at that point, which is this x minus x0. Okay, now it was given that this line passes through origin. Now if it passes through origin, your x and y should be 0. So we've done that here. So it will become 0 minus y0. The slope will come as it is, and 0 minus x0. Okay, so your minus and minus also cancelled out to balance it. Now we will put this value of y in terms of x from here. Okay, तब ये single variable में आएगा, तब ये solvable होगा. Okay, so this y of y0 which was here will be substituted here. Okay, now you have x cubes, y x to the power of 5, put them all together. This is the equation that you are getting. Factorizing it, 8x naught cube, and then you're left with x naught square minus 1. I've taken that minus sign also common, don't get confused. Okay, it will become 1 minus x square, comes to the same, 1 minus x naught square. Okay, so from here we get the value as x0. From here x square is equal to 1, so x0 is equal to plus minus 1. Two values you will get. Under root aap khud loge na. Alright, find the corresponding y from here, put the values. If x was 0, y is coming out to be 0. If x was 2, it is coming out to be 2 minus 2, that is plus 2, and if it was minus 2, then this will become minus 4, this will become plus 2, so it will come out to be minus 2. So you're getting 3 points at which if we draw tangents, they will pass through origin. Get that? Okay, then what is the 19th question saying? Find the point on the curve at which the tangents are parallel to x-axis. I think you'll do it on your own, children. Okay, because tangent parallel to x-axis, you know, is dy by dx is equal to 0. So do that, find the derivative from here, equate that to 0, solve it, find your points, and then find the equation was also required. No, you simply have to find the points. If equation is also required, once you know the point and slope, writing the equation is also not difficult. Okay. Next we are saying find the equation of normal now to the point. अभी तक tangents चल रही थी, अब normal, so that's no big deal. We've dealt with normals as well. Just you have to, in place of dy by dx, consider the slope as minus of dx by dy. उसको reciprocate कर देते हैं हम negative times, because we know when two lines are perpendicular, the product of their slope is -1. Okay, so this time we have to find equation of the normal at this particular point for this particular curve. So although that's simple again, but still I've done it for you because there were some variables here, and also it's for normal first question. Okay, so that was your curve given to you. Differentiate that to find your dy by dx. Okay, a y square tha, so y square ka derivative 2y, a scalar will come as it is, and then dy by dx you have to put, and is equal to 3x square. So from here your dy by dx is coming as 3x square minus 2ay. That was your dy by dx. But since we were to talk about normal here, so I have not evaluated dy by dx. It's your choice. You can first find dy by dx, and then for slope of normal you can negative times the reciprocal of that can be considered. Okay, anyways, I've done it here straight away in the calculations. Slope of normal then we know is minus dx by dy. So isko ulta kar diya hai. Minus 2a, in place of y will come this point y, and in place of x has to be substituted am square. Okay, so simplifying, the slope of normal is coming out to be minus 2 upon 3m. Therefore, the equation of the normal is, the points were given to you. So y minus y0 and is equal to slope of normal already evaluated, x minus x0. Cross multiplying, simplifying, you could have taken from here a and m square is coming common. आप उसको common भी ले सकते हो, your choice. Okay, so that is your required normal. Fine. Okay, then the next page we have more questions. Find the equation of the normal to this curve which are parallel to this particular line. Children, now you try that on your own. Do it peacefully, not difficult at all. You just need to focus. Okay, equation of normal nikalna hai, so you have to remember, of course, first we will find dy by dx, but then for slope of normal we will consider minus dx by dy. Okay, and it is said that the normal is parallel to this particular line. So parallel to this line means यहाँ से इसका slope निकाल लोगे आप. Slope of this line will come out to be minus 1 upon 14. Okay, take it to the other side. Minus 1 upon 14 आ रहा है इसका slope. So minus 1 upon 14 will be equated to minus of 1 upon 3x square plus 2. ओके, इसका डेरिवेटिव जो आप करोगे उसका माइनस टाइम्स द रेसिप्रोकल कर दोगे, क्योंकि नॉर्मल की बात हो रही थी, एंड नॉर्मल इसके पैरेलल था, तो इसका स्लोप एंड नॉर्मल का स्लोप इक्वेट हो जाएगा. फाइन, देन यू हैव टू सॉल्व दैट इक्वेशन टू फाइंड योर एक्स एंड वाई. What was the question? Find the equation of the normal. Yes, so you'll have to find x and y both, and then you'll have to use that equation. Y minus y naught is equal to minus dx upon dy, x minus x naught. Fine, so you do it on your own, children. The next question also you'll do on your own, finding equation of a tangent as well as normal to this parabola at this point. So अभी मैंने एक parametric equation आपको करके दिखा दिया है in question number 20, where they had asked us to find equation of normal. Here they are asking us to find tangent as well as normal. So tangent में slope dy by dx रख लेना है, normal में minus dx by dy. That's the only difference. And point given to you, curve given to you, you can find your dy by dx. Won't be difficult. Okay. Then next is you have to prove that these two curves cut at right angles. Now children, if two curves are cutting at right angles, then their what do we say? Tangents are also going to be perpendicular naturally. Okay, so two curves cutting at right angles means their tangents will be perpendicular. Their tangents will be perpendicular means slope, product of the slope of tangents should be minus 1, means dy by dx of this into dy by dx of this is equal to minus 1, because they are perpendicular, right? And that will help you find your this relation. But yes, of course, what is important here is the point of contact is not known. Unless you know the point of contact, आप equations form नहीं कर सकते हो. तो यहाँ पे आपका proof नहीं आएगा unless you know the point of contact. Okay, so you'll have to find the point of contact, and point of intersection. The point of contact for the tangents out here will also be the point of intersection because they are cutting each other. Okay, so point of intersection ke liye you just have to solve the equations simultaneously. Fine. So that was your question. Those were your two curves. This was curve 1, this was curve 2. We'll differentiate to find dy by dx of both. All right, and then you will find the point of intersection. In a hurry, I have done that in mix match order, but it is better if we had taken out the point of intersection first. Okay, I have done it later, never mind. So find the slopes, then find the point of intersection. The point of intersection is coming as this. Solving them simultaneously. This was your first equation. This sorry, ये तो point निकाल दिया है. Yes, these were your two equations. So substitute in any one, because जब तक one variable नहीं होगा, you won't be able to solve it. So I've replaced this x in equation 2 by y square. So y cube is equal to k. So from here y is equal to 1/3 of 1 by 3rd power of k. Then putting this here, x was y's square. So x will become k to the power of 2 by 3. Okay. So this is your point of intersection. K to the power of 2 by 3 and k to the power of 1 by 3. All right. And now then you move on to, it would be better that you find this first. So I've explained it in that order. Next, since we know that the curves are perpendicular, so the product of their slopes should be -1. Okay, dy by dx of first curve into dy by dx of second curve at the point of intersection should be -1. So from here, put the values of the first slope into second slope, which is equal to -1, and then this you could have cancelled here. Anyways, I've done it after substituting the point. Okay. So 1/2, this and this gets cancelled, and in place of x comes our x coordinate, which was k to the power of 2 by 3, will be equal to -1. And since this was negative here, so minus cancels out. And then cross multiplying, you get 1 left here, and this is 2k to the power of 2 by 3. Now if I cube this relation, 1 cube is 1, 2 cube is 8, k to the power of 2 by 3 becomes k square. Okay. So to avoid this fraction, we have cubed both the sides, and that was the condition you had to show, that if these two curves are orthogonal means cut each other at right angle, then this condition will be true. Okay. So that's an important question. At times students get confused in that also, so repeatedly it is asked, but it's not really that difficult. If you peacefully try to understand, it's going to be easy. Okay. Then only 2-3 more curves are left, children, which you will try yourself, because by the end of the exercise, I think your concept should be clear. Okay. So you all let me know whether this is clear to you or not. Tangents and normals, even increasing and decreasing function, these are important applications. You are likely to get questions from here. Okay. So make sure you are very clear with these concepts.